In the previous video, we covered the measures of central tendency. In this video, we'll cover measures of spread. Spread measures are also known as measure of dispersion. They tell you that how much your data is spread. There are primarily four measures of spread. Looking from left to right, it's standard deviation, variance, interquartile range, and range. We'll talk about the range and interquartile range first, and then we'll talk about standard deviation and variance. Range is simply maximum minus minimum. If you look at the Reed score, so Reed score is what we have analyzed till now. If you look at the Reed score, which we have analyzed till now, if you want to find out the range, so range is simply maximum minus minimum. The minimum marks one of the student has got is 28, and the maximum marks, if we scroll down to the bottom of this table, the maximum marks is 76. So range is simply maximum minus minimum, which is 76 minus 28. To understand interquartile range, let's understand the quartile. And before we understand quartile, let's take a refresher at what is median. So median is a middle value. And let's talk about this representation. We have an observation here. Let's say observation number 1 to 200 are laid down in an ascending order. And the Reed score corresponding to each observation is, for the first observation is 28 because 28 is the minimum. And for the last observation is 76 because the maximum Reed score is 76. If you want to find out the median would be exactly the middle value, would lie somewhere around here, which is the 100th observation. And the median that was coming up next to the 100th observation in this table was 50. So this is the median. Next to the 100th observation, it's 50. So our Reed score 50 is represented like this to represent the median. So median divides your data into 50%. 50% on the left, 50% on the right. Now just like the way you have median, you have quartile. So quartile divides your data on the basis of 25%. Where median divides data on the basis of 50%, quartile divides data on the basis of 25%. So the first 25% of data would become the quartile 1. So in case you have 200 observations, the observation number for the quartile 1 would be 200 divided by 4, which is 50. Next to the 50th observation, the Reed score that is coming is 44. So 44 becomes the quartile 1. Now let's talk about quartile 2. So quartile increases in denomination of 25%. So if Q1 is 25%, I can say that less than 25% of my students have score less than 44 in the Reed subject. Now Q1, you have Q1, Q2 and Q3. Q1 is 25%, Q2 is 50%, so Q2 is the same thing as the median. Now let's talk about Q3. Q3 covers 75% of data. And the number of observation next to Q3 would be, since we have 200 observations, 75% of 200 would be 150. So the observation next to the 150th observation would be your Q3. So let's take a look at the 150th observation. In the 150th observation, the score that we have next to Q3, which is the 150th observation, is 60. The Q3 becomes 60. So how do we interpret Q3? We can say that 75% of the students in class, they get marks less than 60. Now in case you want to find out the range, we discussed the range is, this is the minimum score and this is the maximum score. Range is maximum minus minimum, which is 76 minus 28. And similarly, interquartile range is Q3 minus Q1. Which is 60 minus 44 in this case, which is 16. The interquartile range is 16. Now, how do we interpret the interquartile range? So interquartile range is effectively middle 50% of the data. Underlined in red color is the interquartile range. So this is middle 50% of the data. Since Q3 is 75%, Q1 is 25%, interquartile range is Q3 minus Q1. It is effectively middle 50% of the data. And you get the interquartile range as 16. You can say that your middle 50% of data has a dispersion, has a scatterness of 16 marks. While the range was 76 minus 28, So range would be always quite high as compared to interquartile range. To understand quartiles is not impacted by outliers. However, range is impacted by outliers. Outliers means an extreme observation. So if one of the observation is extreme, which means the student has either got very low marks or very high marks, your range would be affected by that. Let's take an extreme scenario that range in our case is 76 minus 28. So in case one of the student has got, instead of getting 76 marks, the student has got the highest marks is 90. And the lowest marks instead of 28, it's 10. Let's take a hypothetical scenario. So your range would become 80 in this case, 90 minus 10. Range would become quite high, which means that the range is being impacted by outlier. However, on the same data, in case you change first and last record, which is the minimum and maximum value from 28 to 76, if we change it to 10 and 90 respectively, the interquartile range would not be impacted. So interquartile range is not impacted by outliers. Similarly, if we talk about the median is not impacted with outlier. However, mean is being impacted with outlier. So we can play around with this data. Right now, let's say one of the student has got 68 marks in read subject. And in case I replace this 68 marks with 10 marks. So here you see the mean and median, which is 52.23 and 50. You would see that the median is not impacted, but the mean is being impacted. Mean now came down to 51.94 because of this outlier observation, which is the marks 10 in the read subject for one of the student. However, the median was not impacted. Median is exactly the same. Now that we have discussed about the range and interquartile range, let's talk about standard deviation. And variance would be similar to standard deviation. So standard deviation is average of deviation of each observation from the mean of the data. Let's try to understand this definition. This is a high-level view of the standard deviation. Let's try to understand this definition. So in this particular Excel, there is a tab by the name of standard deviation, and this Excel file would be uploaded on the Udemy portal right next to this video. To understand standard deviation, let's consider this highlighted table, which is school A. So school A, let's suppose, has 5 students, and these 5 students have got marks in the read subject. So the marks that student have got, looking from the first student to the last student, the marks that student has got is 50, 51, 52, 53, and 54. And the average is coming out to be 52. So the average of all the students is 52 marks in the read subject. Now what is standard deviation? To understand standard deviation, let's try to understand the dispersion, the scatterness of the data. So the average that we have calculated is 52. This is the average. And if you look at this average, how far is this average from each of the observation? Across the average, you would see that these are the observations, which is 50, 51, 52, 53, 54. These are each of the students. If you look at the scatterness, so the distance of these red lines, they are defined on the basis of the difference between the mean and the each observation difference. So if it is quite far away, the distance is represented high. For example, a student who has got marks of 50 is 2 units away from 52 and the distance is high. Similarly, a student who has got marks of 51 is relatively nearer to the mean. It's only 1 unit away from the mean. So we are taking absolute values, we are not taking negatives. Similarly, a student who has got marks of 53 is relatively nearer to the mean. He's just 1 unit away from the mean or 1 marks away from the mean. A student who has got marks of 54, he is 2 units away from the mean. 52 minus 54 is 2. And this 52, the student who has got marks of 52, he is the mean itself. He has the mean score itself, so that's 0. In case we have to find out the deviation, so these are deviations. 2, 1, 2, 1, these are deviations. In case we want to represent this deviation into one statistic, we can simply take average of all these deviations. So since there are 5 observations, the average of all these deviation is 2 plus 1 plus 2 plus 1, that is 6 divided with 5. This comes out to be 1.2. So you can say on an average, each student is 1.2 units away from the mean, which means that these data points are very close to each other. Now if you take a look at the school B, which is the table below, the highlighted table, if we try to find out the standard deviation or average of deviation, towards the right side is the representation. So the average is coming out to be 66, and in a similar way, if we do the representation, the highlighted is the representation that comes up to be. And you can apparently see the distances are very high of each observation from the mean of the data. This represents in school B, the scatterness is quite high, the data points are quite scattered, and the average of deviations would be quite high in the school B as compared to school A. So the deviation would be higher in school B and it would be lower in school A. So standard deviation represents the scatterness of the data. Now if we look at the standard deviation formula is not exactly the same that we discussed in form of the scatterness and average of deviations. That was just a way to understand what standard deviation is. However, the formula is little different, which we will talk about in a while. If we talk about the formula for the standard deviation, if we calculate it by the formula, look at the yellow cells. So 1.02 is the standard deviation for school A. It's not coming out to be 1.2, it's 1.02 as the formula is different. And the standard deviation for the school B is coming out to be 14.91. By looking at standard deviation, we can see that the school B has higher standard deviation than school A. By just looking at standard deviation, we can talk about that how much scattered the data points are. Is the data scattered? It tells us the dispersion of the data. That is the reason why standard deviation is a measure of spread. The exact formula for standard deviation is summation of x minus mu. So mu is the symbol for mean divided by n. N is number of observation. And the standard deviation is denoted by sigma sign. To understand standard deviation exactly, we'll do x minus mean, which means for each observation we'll do 50 minus 52, and we will do it across all the observations. 50 minus 52, 51 minus 52 is minus 1, 52 minus 52 is 0, 53 minus 52, which is average, is 1, and so on. So we calculate x minus mean, and then we just take square of it. So if we take square of x minus mean, so it's minus 2 into minus 2, and we do it across all the observations. So this becomes the component in the formula as x1 minus mu whole square. And then we take summation. This is the sign for summation. In summation, we'll take sum of all these values that we have squared up. This becomes a summation of x minus mu whole square. And we divide it with number of observation and take square root of it. To find out standard deviation, so this is the summation 10. We'll divide 10 with the number of observations, which is 5, and take square root of it. The square root of 2 would be 1.41. And we'll just correct the range of this. So range of the standard deviation, I'll correct this in the Excel. Now it would become 1.41. So this standard deviation is exactly the same as what we have calculated through this formula. Let's correct the range for this standard deviation as well. And apparently we can see school B has higher standard deviation than school A, which means that the school B students are very different from each other and school A students are not very different from each other. They are more alike each other. Now there's another measure of spread, which is variance. Variance is exactly the square of standard deviation. So if you just remove the square brackets, that would become the variance. So variance can be represented as a standard deviation formula. You just don't need to mention the square root here. Now variance alone is not very helpful. You cannot draw the insights from variance, but variance is used for building up the variance covariance matrix, which is used to calculate in linear regression the beta